Number 4. The function f of t equals 16t squared represents the distance in feet a dropped object falls in t seconds. The function g of t equals s naught, okay, that's called s naught, or you could say s sub 0, represents the initial height in feet of the object. Letter A. Find and interpret h of t equals negative f of t plus g of t. Okay, so let's see what they're talking about here. So first of all, we have to find a function for h of t. So h of t equals. Now we have negative f of t. Well, f of t is this, and we want negative that. So we're just going to put negative 16t squared. Plus g of t, well, g of t is this. So we're going to do plus s naught. That is going to be your function for h of t. Now it says we have to interpret that. We've done one little example of this before. Maybe you remember it, maybe you don't. But if we're going to interpret this, if you remember, I said that whenever you drop something off of a roof, you can drop it or you can throw it. It can have a velocity or it can just be dropped. In this case, we are just going to drop it, meaning we're not going to have initial velocity. But when you drop something, it's going to fall, and it's going to fall due to gravity. So when you're dealing with feet per second, the negative 16 is the effect of gravity. And the reason it's negative is because the gravity is going to pull it down to the earth. So your parabola, if you were going to graph this thing, which is a quadratic, is going to have this thing going down. So your parabola is going to be upside down. Then the s sub naught is going to be your initial height. When you drop this thing, were you 100 feet in the air? Were you 200 feet in the air? How high were you actually in the air when you dropped it? And then how far does it have to go to get down to the ground? So letter B, an egg is dropped from a height of 64 feet. After how many seconds does the egg hit the ground? Okay, well, I have this function. This function represents my egg, represents the distance in feet a dropped object falls in t seconds. So, first of all, it's dropped from a height of 64 feet. That's the initial height. So I'm going to take my function, and right here, I'm going to substitute in 64. So equals negative 16 t squared plus 64. Now the other thing I'm going to do is it says after how many seconds did the egg hit the ground? And right here, h of t represents the distance in t seconds. Well, if I want to know when this thing is going to hit the ground, what distance or how high is this thing in the air at the ground? Well, that would be 0. It's not in the air at all. So instead of h of t, I'm going to substitute in a height of 0 because I want to know t, meaning find the time that this thing is on the ground. So find t when h is 0. H of t is height, t is time. Now we have this equation. Now, there's a lot of different ways we can solve this equation, but so far in this math class, I've taught you one way for solving a quadratic equation, and that's to solve by factoring using your zero product property. So here is a great reminder of how we factor. First thing I'm going to do is, because my leading term is negative and I don't like that, is I'm going to factor out the GCF. And actually, I'm just going to divide my entire equation. Now, my entire equation, I'm thinking I could get out a negative 16. And then just to make sure that I'm not making any mistakes here, I'm going to grab my phone and I'm going to take 64 divided by negative 16. So 64 divided by negative 16 is negative 4. So on the left, I'm going to have 0 equals t squared minus 4. Then I'm going to keep factoring and I'm going to look at t squared and go, oh, that's t times t. And there's 4, and that's 2 times 2. That's difference of squares. So if you remember, that's going to factor into a t plus 2 and a t minus 2 equals 0. Now that we have this factored, we can use our zero product property, and we can say t plus 2 equals 0, and we could do t minus 2 equals 0. And then we can subtract t off the first one. So t equals -2. Add t to the second one. So t equals 2. Now keep in mind, you're trying to figure out after how many seconds this thing is going to hit the ground. Well, we're not going with negative seconds. We're not going back in time for an egg to hit the ground. So after 2 seconds, the egg will hit the ground. Letter C. Suppose the initial height is adjusted by k feet. How will this affect part B? And again, don't overthink this, okay? So remember in vertex form, we had an A, we had an H, and we had a K? And the K was like the +5 or -2. It moved it either up or down. Well, if I adjust the initial height by k feet, let's say I adjust it by 10 feet. So instead of 64, we're at 74. How is this going to affect my answer in part B? Well, if I move the egg higher, it's going to take longer to hit the ground. Well, what if I move the egg down? What if I adjust it by -10 feet? So instead of 64, it's at 54. Same idea. Well, if I move the height lower, it's going to take a shorter amount of time to hit the ground. So if k is greater than 0, longer to hit ground. Okay, meaning if k is 1 or 2 or 3, you're moving it up. So it's going to take longer to hit the ground. If k is less than 0, shorter to hit ground. Now, I put k is less than 0. What can k not be? Can k be -100? And I hope you're saying no. And the reason is because we started at 64 feet. So if I move it down -100, how do you take an egg, which is just 64 feet in the air, and move it lower by 100 feet? You'd be in the ground. Okay, so actually, we got to be less than 0, but we also got to be bigger than -64. Because if you go -65, you're below the ground. We're not even going to deal with that.